Hi guys, welcome to your second lesson on Unit 5. Today we are talking about energy flow, which is just the flow of energy. Our objective today is to demonstrate the flow of energy by creating an energy pyramid for a food chain. Okay, so that's our end goal, and that's what we're going to do the last couple minutes of this lesson. You should be watching this on the 8th or 4/9. And so today is the second day, so we are right here. We will have a quiz posted here. I'm not going to have it due until 4:13 at midnight because today, the 10th, this day, is technically a bad weather makeup day. You do not have to do schoolwork on that day. Okay? Just so you know. And that's also Good Friday, so hopefully this is the last video before Easter, so have a happy Easter. So food chains and food webs, what do you know about them? You should have learned them in 5th grade, and you should have also learned how to refresher in 7th or 8th grade. So we should basically know what they are, but we're going to go over what they are in case you don't. A food chain is a route for the transfer of matter and energy through an ecosystem. Okay, so basically the main thing that we talk about is energy. So we're transferring energy, but it's also, we get that energy through the transfer of matter. And what that basically means is that they're eating each other. We've got prey and predator situations here. This is a term that you do need to know, trophic levels. Okay, a trophic level is a position in a food chain. So I'm going to write that down as a position in a food chain. And your trophic level can be that you are a producer, a primary consumer, a secondary consumer, a tertiary consumer, or a quaternary consumer. So basically you're a producer or a consumer, and you're either the first, the second, the third, or the fourth consumer. And that's all that means. If you kind of try to think about what other words you recognize or you've learned before with troph in them, two that hopefully come to mind are two that we just talked about. If you're going to be an animal that makes their own energy, like a plant, we say that you are autotrophic. And if you consume other things for your food, you do not make it, you are heterotrophic. So those are two terms. We've seen this word trophic before. So trophic level is just one of these different levels. The next thing that we're going to talk about is how the energy moves through the food chain, okay? Because energy is moving through the food chain. It passes between these different levels. It always starts with the producer, okay? Producers are what you probably can think of. They're plants. They're going to produce their own food. Plants. The next level that we have is primary consumer. Primary just means first. They're the first consumer. And they are herbivores. Okay, and if you did not know what an herbivore is, hopefully y'all do, they eat plants. They do not eat meat. So they only eat plants. So if you're a human and you're an herbivore, you're most likely a vegetarian. So herbivores just eat meat, and that would be the next level. So obviously our producer over here is going to be our green plant in this picture. Our primary consumer, I'm going to do blue because they just eat those plants, are going to be things like mouse, rabbit, this goat. The next level that we're going to have is secondary. And if you don't know what secondary means, it means second. You're going to be a secondary consumer. And those have to be carnivores. Okay? And then you can have a tertiary consumer, a quaternary consumer, which is the 4th level. But no matter how many times it passes from these different levels, it will eventually lead back to decomposers. And decomposers break down dead material. So after this lion dies, the decomposer will utilize its matter and give the nutrients back to the plant. And we're going to see a food web that shows that. If you look at this food web, sorry, if you look at this food chain in an ecosystem, it actually creates, I keep saying that word, food web. And we're going to talk about that in a little bit. For each, I have a little practice here. For each of the examples below, you can pause the video and you can write down if it is a producer, a consumer, or a decomposer. And if it's a consumer, you need to specify whether it's a herbivore, carnivore, or omnivore, and I'm going to define those terms up here. So now with those terms defined, pause the video and give this a shot. In a second, I'll have all my answers pop up. So here are the answers. You cannot read my handwriting. It's also color-coded to the best that I could. Producers are in green. There's only one producer. It's grass. Consumers are pretty much everything except for our decomposers, which are fungi. So if it is a fungi, and fungi, again, are mushrooms, molds. If it says it's a fungus, you're going to know that that is a decomposer always. So we talked a little bit about this, but a food web shows all the possible relationships in an ecosystem at each trophic level, versus a food chain, which just shows a network of interconnected animals. And I have a good comparison here. So this is the whole food web. This shows all the possible animals that could eat all the different things. And over here we have a food chain. It's just one possible chain. A food chain is a part of a food web, but a food web is not part of a food chain. Okay, so we could pick up this food chain and put it into this food web, but it does not go the other way. Okay? When I show you these pictures, make sure you're noticing on this picture, we have energy from the sun, which we're going to talk about in a little bit. But most energy for all animals on Earth comes from the sun, because the sun actually gives energy to things that can photosynthesize or make their own energy. Things like dinoflagellates and diatoms, those are they're actually photosynthetic organisms in the ocean that receive energy from the sun, make their own energy, and eventually these other things like shrimp, copepods, and ocean sunfish, the energy is transferred to those eventually. And I did not realize this question was here, and I just gave you the answer. But if plants are the main producers for terrestrial ecosystems, where would the flow of energy be produced in aquatic systems? I kind of just gave you the answer, but you could also come up with other ones. Again, this is a stop and think, not a turn and talk. But like we just talked about, those dinoflagellates, diatoms, algae is another good one. I have some listed on this slide. You might see, again, this diatoms, seaweed. Those are all different types of producers. But this slide is specifically here because I'm going to put the password for the exit ticket within my video instead of at the end. So password for exit ticket is going to be aquatic, lowercase a. A-Q-U-A-T-I-T-I-C. Okay, aquatic is the password for the exit ticket. I clicked back to this slide because I forgot to talk about a very important thing. If you notice, the arrows are going in a very specific way in food webs and food chains. The point of the arrow is not to show what is eating what. This tree is not taking a bite out of that goat. That's not what's happening. The arrow equals the flow of energy. So this is showing that the tree is giving whatever energy it has to the goat. That means that the goat is, in fact, eating the tree. Okay, so same thing up here. This wildcat is not taking a bite out of our lion, okay? Our lion is eating that wildcat, and the energy is flowing from the wildcat as nutrients to the lion when it eats it. So that was just a quick thing before we do our practice right here. This practice is I want you to name one producer. Okay, this shows a food web, and although we might not know what amphipods are, and what ratfish are, and what zooplankton are, and tubefish, and mussels, and cyanobacteria, you can always find the producer because it has nothing pointing to it. It is where energy is starting. No energy is coming from it. The only thing that might be pointing an arrow to it is the sun. So the sun is going to give our energy to things like cyanobacteria. So if you see sun pointing or energy pointing to something, you know that's always going to be our producer. So our two possible producers in this picture are chemosynthetic bacteria and symbiotic bacteria. Okay, again, you don't really need to know what they are. You just need to be able to identify them. Okay, and if you remember, what is a primary consumer? A primary consumer is going to be the first thing that is going to eat that producer. So it could be something like amphipods, zooplankton, tube worms, and mussels. Okay? Now, what would be our secondary consumer? It's whatever eats the primary consumer, right? I should not draw my arrow that way because that's not the way the energy is flowing. So it would be my Galliphield crabs, zooarctic fish, my ratfish. And I actually only have one tertiary consumer, and that's going to be my octopus, all the way at the end. Okay? Now on this example, I want you to pause it, and I want you to try and do it on your own. So here's a second to pause it. Pause the video. Everyone paused it? Okay. I'm still going to go through these questions. So the first one is, which organisms is both a tertiary and a secondary consumer? So if I'm going to go off of the colors I had in my last video, again, this is my producer. Blue is my primary consumer. Purple, I'm going to do like diamonds. So if you only have a pencil and you don't have multiple colors, you can just do different shapes, is my secondary consumer. But if you notice here, I made a mistake in the last one. Octopuses are also secondary consumer because they eat mussels, which are a primary consumer. Okay, so octopuses are also a secondary consumer. And that also means that octopuses are also our tertiary. So the answer for this first question is octopi. And then what trophic level is missing from this food web? We have consumers, we have producers. If in your mind you said decomposers, you are right. Decomposers are missing from this food web. Okay. The next thing that we're going to talk about is how a food web might also be portrayed as a food pyramid or an ecological pyramid. An ecological pyramid is just a pyramid that shows the feeding relationships of groups of organisms and the flow of energy through the different trophic levels of that given ecosystem. So I'm going to show y'all an example. So here we have our food web. We've already talked, the arrows represent the flow of energy. We know that that is where the energy is going to because that animal's eating the one before it. But what we didn't talk about is how much energy is transferred when this jackal eats the goat and when the goat eats the tree. Depending on their level, they get actually a different amount of energy. And only 10% of the energy is available transfers to the next level, okay? Most land ecosystems only have 3 or 4 levels. If you notice, we have producers, primary consumer, secondary consumer, and it usually stops at tertiary consumer because at that point, the energy levels are so low, it's ineffective to even spend energy hunting a prey down and eating it. And you're going to see an example of this in just a second. So what we mean by only 10% of the energy moves on is that if my producers all the way down at the bottom, they get 100% complete energy from the sun. My primary consumers that are going to eat my producers are actually going to get 10% of that 100, which if you know anything about percents, you know that that's going to be 10%. Now my secondary consumers, they only get 10% of that 10%, which is actually 1%. And so that means my tertiary consumer, my big lion, he's only going to get 0.1% of the original amount of energy that we had all the way down at the bottom. So that's what we mean is the energy is almost insufficient. If we were to have another level up here, that level would only get 0.01%. That's just not enough for an animal. So that's why there's usually only 3 or 4 levels in an ecosystem. Where does the rest of the energy go? The other 90% of the energy is lost as heat to the environment. Okay, so I have a trick for solving problems. This is telling me that my producers have 20 20,000 kilocalories, which you would write kcals like that. So there's 20,000 kcals all the way down at this bottom of this triangle. How do I find how much my primary consumers are? Now, yes, you could get out your iPhone and you could type in 20,000 times 10%, which would be, if you know how to multiply a percent, you would do 0.1 and it would give you an answer. But I have a little trick. Every time that you are only moving on 10%, all you have to do is move the decimal point. Okay, so if my 20,000 is right here, if 10% moves on, I'm going to move my decimal point over just one hop. Okay, so I should have done this in blue for my primary consumer. So my primary consumer is going to get whatever that new number is, which is 2,000 kcals. So I'm going to put 2,000 kcals in my next level of my pyramid. Now I'm going to do the same thing again. My secondary consumer is going to come along and eat this thing and is going to move my decimal point 1 over. And that means my secondary consumer is only going to get 200 kcals. 200. Okay? Pause the video. How many kcals is my tertiary consumer going to get? Awesome. If you are unpaused and you are with the video, you should get 20 kcals. Okay? So how much energy is provided to the tertiary consumers? Just 20 kilocalories of energy. That's a very big difference from this 20,000 kilocalories that my producers got. So that's all the practice that I'm going to go through. I'm going to go through two more practice problems, but if you want to dip out here, you have your exit ticket password. If you remember, I showed it earlier in the video, so you should go back to where I showed it if you already forgot it. But I do have a worksheet that is posted on Google Classroom. And in class, we would have done different stations, and y'all would have gone to different stations and done the practice. Those stations I just put into a Google form, so y'all have time to practice now. You absolutely should go do that. The answers should be automatic. Again, sometimes the answers mess up. Let me know if they don't come across right. But I have 3 minutes for each station, and there's 5 stations, so this should take you about 15 minutes to do. If you need more time, take more time, obviously. But obviously we're not rotating and doing things like that. Just go to that Google form. It's under today's lesson. That's just kind of our new norm. And then you do have independent practice, or just call it homework. Call it what it is. It is homework. It should take you about 25 minutes. And so that would be our hour lesson for the day. Of course, as always, Miss Lynn's giving you choices, mild or spicy. Each of you should have your own copy of both of these. You should just go into the Google Classroom assignment and click open with Google Docs and fill it out. That's all you should be doing right now. Okay? Open with Google Docs and you should be able to fill it out. I challenge everyone to do the spicy or both if you have extra time and you're bored, but you don't have to do both. But if you want to leave the lesson, that's fine. If you're sticking with me, I do have 2 more practice problems I'm going to run through, so if you need more practice, stick around. Okay, for all my people who still need a little bit more practice, we're going to do these. We're going to do 2 more problems really quickly. Okay. This first one shows a food web. And the first thing it's asking us is to identify 3 producers. And I can't write in that tiny line, so I'm just going to color code things. But remember, how do I identify my producer? Will my producer have any arrows pointing to it? Will it be getting its energy from anywhere? If you said no, good job. Okay. Our producers are not getting their energy from anywhere. So I would circle the things that are not getting energy from anywhere. In this picture, I see one right here, clover, all the way down at the bottom. I also see oats kind of here in the middle. I have arrows going out from it, and it's kind of in the middle of our thing, but if you look at it, there's no arrows pointing to it. And my last one is sunflower. Okay, the next one says just identify 3 consumers in this food web. Well, if we look at the rest of this, all of these are consumers. So you could literally put whatever you want, but let's walk through some of these. Okay, I'm going to do my primary consumers in blue. Put prime consume. I have a rabbit right here. That's a primary consumer. If I follow my oats, the first thing that eats it is my grasshopper. That's a primary consumer. But if I also notice over here, my oats leads also to sparrow. And it leads to field mouse. That's another primary consumer. And it leads to, oh, I think that's it. Let me double check. So those are all my primary consumers. Now, my secondary consumer is going to be anything that eats a primary consumer. So I see that energy can flow from my clover to my rabbit to my red hawk. So my red hawk's going to be a secondary consumer, but it can also flow to my grasshopper and then anything that eats my grasshopper, which is going to be my toad. It also can flow from my oats to my sparrow all the way to this hawthorn snake, or my oats to my grasshopper to my garter snake, or even my oats to my grasshopper to my spider. There's lots of different things that could be happening here. Kind of an extension question, but I'm going to challenge y'all. Can you find any on here that are secondary and tertiary? Okay, I do see one, and that would be something that eats a primary consumer, but it also can eat another secondary consumer. Okay, and there's actually three on here. Okay, what you want to look for is a lot of the same color pointing to each other. So right here we see our spider. He got his original energy from the sunflower to the field mouse to the spider, and that can eventually lead to the toad. So that can be one of our tertiary consumers. And then over here we also have a gardener snake leading to the red hawk. That's also another tertiary consumer. Now what's really weird is on here we have a quaternary consumer, and that bad boy is this hawthorn snake. Or hagnose. I've been saying that wrong. Hagnose snake. Okay, now we're going to answer this question all the way down here. Okay, in this ecosystem, is more energy available to this mouse? So I'm gonna erase all of this and find our mouse, or erase a lot of it. Find our mouse. Is more energy available to the mouse population from eating spiders or eating oats? So when I have a question like this, I like to use some theoretical numbers. Let's say that we have 1,000 kilocalories of energy in our oats. Okay. Now we have two paths. We can either go through the grasshopper, to the spider, to the field mouse, or we can just go straight to the field mouse. Now you might know the answer all the way right off the bat, but let's go ahead and walk through the math on this. So let's say my oats start off with 1,000 kilocalories of energy. My grasshopper is going to get 10% of that. So if you can do the math in your head pretty quickly, my grasshopper is going to get 100 kilocalories. Now, my spider is going to get even less than that. He's going to get 10% of that 100. That means he's going to get 10 kilocalories. And what is my mouse going to end up with? My mouse is going to end up with 1 kilocal of energy. Okay? So that's option number 1. Option 1 equaled 1 kilocal of energy. Now we're going to go through option 2. I'm going to pick a different color. Option 2, I'm going to do an orange because I don't have on the board. Again, we're going to start with 1,000 kilocalories of energy. And we've actually got one arrow to my field mouse. That means my field mouse is going to end up with 100 kilocalories of energy. What's our better option for our mouse? Do you want 1 kilocal of energy or 100 kilocal of energy? If you said the 100, you are correct. Good job. Okay, that was my last big example. That was a lot at once, I know. I have a challenge for you here if you want to do it. This is just designing and constructing your own food web. This describes what animals are eating what. You would draw arrows. I'll post my answer to this on Google Classroom somewhere. But this is going to be a challenge. If you choose to accept it, you can upload a picture. You can email me a picture to mlynn at uplifteducation.org. But this is not required. This is just a fun challenge. Fun challenge. Okay? That is optional, I should say. Optional fun challenge. Okay, and that's it for my video. Things that you have to do. You have an energy flow worksheet. You have energy flow homework. You have an energy flow exit ticket. Lots of energy flow things too. And then the major thing that you want to remember is that you have a quiz that will be posted on, I will post it on Thursday. So that will be 4/9. And it'll be due not until Monday night, 4/13, just because I'm giving you a little bit extra time to get it in if you need that extra time. You can join me from Zoom Wednesday or Thursday. I will not be there Friday from 1:30 to 2:30. And on Wednesday, we will be doing a Kahoot game. So if you want to come and review some of these topics, we will be playing a fun Kahoot. So I'll hope to see y'all then. Bye.